Hi everyone, and we're back with looking at one of the problems. So here this problem is stating that we must use Newton's divided difference method to construct interpolating polynomials of degree 1, 2, and 3 for the following given data. Then for each case we must approximate f where x is 8.4 given these data points. So first thing that you want to do is set this up in a table. That table we will want to have a value for n, and here n is just going to be counting up from 0. So I'm going to go 0, 1, 2, and 3, because we've got 4 data points. So we've got data point, the first one, which is going to be our 0th data point, our first, our second, and our third. Next, we want to have a column for x. So in this, I'm going to just separate it like that because it just makes it nice and neat. And at x, we have 8.1, we have 8.3, 8.6, and 8.7. Then we have our f of x. This is quite long numbers, so I'm going to try to fit it in. Let's go 16.9441. I'm going to omit the truncated 0. Next term we have 17.56492. Then we have 18.82. Nope, we don't. We have 18.50515. And then final term we have 18.82091. And I'm just going to put a line there as well, just to make it nice and neat. So what I'm going to be doing here is I'm going to be working out the terms below and then adding them to the table above, because we're not going to be able to fit everything in just in this table. So I'm going to label this next term first dd, and the dd is for divided difference. So if we go down, if we go down, such that we can still see it, we want our first divided difference. So first divided difference, and that is going to be our formula for our first divided difference, as we had before, is yi minus yi minus 1 over xi minus xi minus 1. So in that case, our y, well, we've got an f of x, which is the same as a y. So our yi, if we're looking at the minus 1, so our first value input there is null. We don't have anything of any use. So our first divided difference is going to be yi, which is going to be 17.56492 minus 16.9441 divided by 8.3 minus 8.1. And if you run that through a calculator, you should get, let me just double check, yep, that should be 3.1041. So that over here, I'm going to just circle it like that. I'm going to put it 3.1041. Now, what we're going to, because they've asked us for the of degree 1, 2, and 3, that means we're going to need divided difference 1, 2, and 3. So what we're going to do is we're going to do the next two values, even though we don't actually need them for the first part. We're going to do them because we need them for the second and third part. So what we're going to have is, if we want y2 minus y1 over x2 minus x1, we land up with 18, I'm just going to do one more, 18.50515 minus 17.56492 divided by, and now we've got 8.6 minus 8.3, and that comes out to 3.1341. And that, if it'll let me move, that we will put over here, so 3.1341. To save time, the third one, if you perform exactly the same thing, so you'll take 18.82091 minus 18.50515 divided by 8.7 minus 8.6. And that will give you 3.1576. And that gives us our first divided difference. Now, let's do the next part of the question. Now that we've got the first divided difference, let's just work out the first polynomial of degree 1. Now, our formula for our polynomial of degree 1, as we had earlier, so p1 of x is equal to our a0 plus our a1 x minus x0. Now our a0, I will just go up so we can see this nicely. Our a0 is going to be this over here, and our a1 is going to be this over here. So I will put a1, I'm going to put red under it, a0, I'm going to put green under it. So when we write that out, we land up with a p1 equals our a0, which is just our f of x0, which is going to be 16.9441 plus, switch back to black, plus, and then we're going to have our a1, which is 3.1041 multiplied by our x minus x0. So we have x minus, and they've asked us to estimate at the value where our x has to be 8.4. So I'm going to put x minus x0. Our x0 in this case, I will use another color just to make it nice and easy to see what's going on. Our x0 is this term over here, and it's that term because under x, this corresponds to our n0, so 8.1, so minus 8.1. And that is our p1 of x formula. So when we're told let x equal 8.4, we're going to go p1 of 8.4 is equal to 16.9441 plus 3.1041, open brackets. Open brackets. Now this is our 8.4, which is our x minus 8.1. And by calculating that, we should get 18.7533. And that is our approximation for our for 8.4. Now, similarly, we now want to work out our second divided difference to get our second degree formula. So we've worked out our first divided difference. Let's put a line. Now we want second dd. Now, once again, we'll be following the same sort of step. We'll be taking this time we're not looking at the f of x, we're looking at the first divided difference. So we're going to take this term minus the term above, divided by, but now we want to have the difference in x. Because we are working with the two divided differences, this is essentially y2 minus y1 over x2 minus x1, and this is x1 minus x0, y1 minus y0 divided by x1 minus x0. So now we're wanting to use our base x's, so we're going to be using 8.6 minus 8.1. So I will do that nice and clearly below. So we want to have our second divided difference. So we can write our second divided difference as first of all, our first divided difference is typically notated as f of square brackets xi, comma xi minus 1. That is typically how you will notate this. Sorry, I missed that. Let's move on to our second divided difference. Our second divided difference is typically notated as f of x0, or f of xi minus 2, comma x of I minus 1, comma x of I. And in this case, we're looking at I is going to be equal to 2, because then we have 2 minus 0, so 2 minus 2, which is 0, 2 minus 1, which is 1, and 2. So when we have that, when we have this, we usually have f of I minus 1 xi minus the lower divided difference, which is f of xi minus 2 xi minus 1. These should be square brackets. Divided by, now here we have xi minus xi minus 2. And a nice easy way to think of it, we've got the I minus 2 over here, and we've got the I over here. It's the largest differences in i's that we're going to be using as our divided difference. So let's work out our f of x0, x1, x2. So our x0, x1, x2, we have our divided difference. So I've got this stuff here in front of me. You can double check. I hope you're writing the stuff down as we're working, just to make it easier so I don't have to scroll up and down. So our x0, 1, 2, if we take our larger divided difference, so our xi minus 1, so this is going to be f of 1 and f of 1, and so f of x1 and x2. F of x1, x2 is going to be, as calculated before, 3.1341 minus our f of x0, x1 is going to be 3.1041. And we divide that by xi minus xi minus 2. So that's when our I in this case is 2. So this is going to be x2 minus x0. So x2 is 8.6 minus x0 is 8.1. So just so you can see where those numbers come from, I'm just going to scroll up to our table because it's quite nice to see graphically. We are taking, I can't see that brush. We are taking this minus this divided by this minus this. Just going to clear those. And our answer that we land up with from here is, let's use a new color. That value we come out with is 0.06000. And let's fill that in our table. So if we go up to here, we now have in our table 0.06. Now we can do the same thing as we did before. We don't need this next term for the second order polynomial, but we will need it for the third. And following exactly the same process, we come out with 0.05875 for that term. And we can put a line. Now let's construct our polynomial, our second order polynomial. And I'm just going to grab this stuff, just so we have a nice easy reference. Pop it in over here. So for our second order polynomial, we land up with, we have our a0, which I'm going to write it algebraically first. So we've got our a0 plus, we have our a1 multiplied by x minus x0 plus, we have now our a2. And that we have over here, a2. And that is going to be multiplied by, that's going to be multiplied by x minus x0, x minus x1. And that's to make sure that we eliminate all previous factors, such that this will only apply when our term is when we are looking at this data point, when we're looking at specific data points. So writing that out, we what you'll also notice is something just quickly to notice. This over here is P1 of x. So to make, because we can see that, I'm going to make this a little bit shorthand and go P1 of x is equal, P2 of x is equal to P1 of x plus 0.06 multiplied by x minus our x0 is 8.1. That's our x0 there, and our x0 there, multiplied by 8.1, and multiplied by x minus our x1, which is 8.3 in this case. I haven't given it a color, but our 8.3 you can see over here. That's our x1. And if we plug in and calculate our x for our value there, you get 17.8773 approximately. And anyway, we want to work out our final options. So once again, the process is exactly the same. We're going to be doing the divided difference here. Exactly the same process as before. So because of that, I'm just going to give you the value. So a dd3, which is going to be f of square bracket. This is going to be x0, x1, x2, and x3. It's going to be all the values, and that's going to be equal to f of square bracket x1, x2, x3 minus f of x0, x1, x2 divided by our largest x term is x3, our smallest is x0, so x0. And when we fill that all in, we should land up getting minus 0.002083. And then constructing our complete formula, this term lands up fitting in on the end. So following the same pattern we see before, P3 of x is going to be equal to P2 of x plus, now we're going to have our new term here, so that's going to come in there. So I'm just going to put minus 0.002083 multiplied by x minus x0, x minus x1, x minus x2. Exactly that process. And once again, you can plug in your values and you can get your estimated value, your estimated term for 8.4. And I'm going to round this video up here, and I'll start the next video shortly.